Question 26, Part C. A class of 30 students sat for an algebra test and a geometry test. The results were displayed in a scatter plot and a line of fit was drawn as shown. Part 1. How many students scored less than 30 on the algebra test? Referring to the scatter plot, we are interested in the number of points that lie to the left of 30 on the x-axis, since the x-axis represents the algebra test result. So counting the number of points, we have 1, 2, 3 points that represent 3 students. Therefore, 3 students scored less than 30 on the algebra test. Part 2. Calculate the gradient of the line of fit drawn. To find the gradient of the line, locate 2 points that lie on the line. And in this case, the 2 points are here and here. So point A has coordinates 40, 30, and point B has coordinates 80, 50. So I've redrawn the line here and I've completed the right angle triangle. And to find the gradient, we use the formula rise over run. Now, the gradient is going to be positive because it's an uphill going from left to right. So to work out the rise, we need to find the difference in the y coordinates. So starting at 30, ending up at 50, that's a rise of 20. So the rise is equal to 50 minus 30, which equals 20. And to find the run, that's the difference in the x coordinates. So that's the difference between this coordinate here, 80, and this coordinate here, 40. So the run is equal to 80 minus 40, which equals 40. So the gradient m is equal to rise over run, which equals 20 over 40, which simplifies to 1 over 2. Part 3. What is the equation of the line of fit drawn? The equation of the line is in the form y equals mx plus c, where m represents the gradient or the slope of the line, and c represents the y-intercept or the point where the line crosses the y-axis. Now in this case, the x-axis represents the algebra test result, capital A, and the y-axis represents the geometry test result, capital G. Now referring back to the scatter plot, we can see that the y-intercept isn't exactly obvious. In fact, the line, if it were to continue, it looks like it's going to pass through a y-intercept of 10, but we can't just assume that. We need to work it out algebraically. And we need to do that by using what we found in part 2, which was the gradient of the line, and using one of these 2 points, which lies on the line, to find the value of the y-intercept c. So from part 2, the gradient m is equal to half, and the line passes through the point 40, 30. In other words, when capital A equals 40, capital G equals 30. We're going to substitute these values into the equation y equals mx plus c to find the value of the y-intercept c. So 30 is equal to half times 40 plus c. Now half times 40 is 20, so the equation becomes 30 equals 20 plus c, hence the y-intercept c equals 10. Therefore the equation is capital G is equal to half times capital A plus 10, or capital G equals capital A over 2 plus 10. Either answer would be sufficient. Part 4. Describe the correlation between geometry test results and algebra test results. We can see from the scatter plot that the direction of the relationship between the algebra test result and the geometry test result is positive. In other words, it's an uphill going from left to right. We can also see that from part 2 when we found the gradient of the line to be positive half. Again, that means there's a positive relationship between the algebra test result and the geometry test result. We can also see that as the algebra test results rise, the geometry test results also rise with it. Looking at the way the points are scattered around the line, there's a moderate spacing between the points and the line of fit. So to summarize, there is a moderate positive correlation between the algebra test results and the geometry test results. Part 5. Mitchell looked at the scatter plot and said, in this class, all students who are near the top in algebra are also near the top in geometry. Explain why his statement is incorrect. Referring to the scatter plot, 4 students achieved above 90 in algebra, and they're represented by these 4 points here that lie to the right of this dotted line. So this dotted line here represents a mark of 90 in algebra. Now, referring to the geometry scores, we can see that the geometry scores varied considerably. The lowest geometry score is around 30 and the highest geometry score is around 70 in this group of 4. We can also see that there are students that achieved above 70 here. So to summarize, looking at the students that scored above 90 in algebra, their geometry scores ranged from 30 to 70, which is in the middle of the range and below the top 2 results in geometry. Therefore, Mitchell's statement is incorrect.